Yes, so my name is Per Olsson, and I will talk about hacking, a mindset, not a skill set. This is me. My name is Per Olsson, and I work at Visma in Sweden. My role as an application security engineer is a type of advisory role, kind-ish, for our development teams. And I have a background as a developer, both a back-end and front-end developer. And sometimes I call myself a ex-developer that is still programming, because I still write code for automations and other things. And as you can see here in the background, some of my hobbies are photographing, hence the camera, and I also do some lock picking with the locks here up in the top. So we have a pretty extensive security program, and with that comes a lot of different stuff, like all of these here. But you know what's most important, actually? That is the training and awareness. And this is also where it all starts. And this is why I chose to talk about the mindset. So basically training and awareness, call it culture or what have you. But it all starts with you. So starting off, what is hacking? Well, if we watch movies and things like that, we often see like this picture here, someone in a hoodie working in a dark room, a basement. There is a lot of dark terminal windows and things like that. But what really is hacking? Well, according to my personal definition, at least, and if we compare it to testing, which is, I think, a pretty simple topic to understand, is, well, testing is when you test if a function works as expected. While hacking is to see if this function can do something completely different by looking at unexpected places and do weird shit. So let's have an example here. So let's say that we have a name field and a hacker would insert this string here. So Robert, single quote and quotation, drop table student. And a tester would just look like, why would even anyone want to do that? Well, a hacker would, and some of you may have seen this short comic here. I'll give it a few moments here so you can have a look here. But basically what this string would do if it's not properly sanitized is that it would actually, if it's inserted into a database query, it will actually end the call here and drop the table if there is a table called student. So as the mother said here, I hope you learn to sanitize your database inputs. So that's kind of what hacking is about. And if we once again talk about Hollywood versus the reality, in Hollywood, we often hear like a hacker voice like, I'm in. But that's not really hacking. And we also see, as I mentioned, a lot of black terminals and so on. But we all know that this is what hacking really looks like. You know, we're all Iron Man and I've hacked into the mainframe and disabled their algorithms. No, to be honest, this is actually how hacking looks like. And it's not much different from how a developer would also work. We spend a lot of time on Google and trying to find things. But if we move on to what motivates hackers, well, I have come to find a few different things that motivates hackers and why they're doing what they does. Of course, there is probably more things that motivates them, but this is at least some of the things that I have found in common. So first is finding new solutions, acknowledgement, sharing, doing ill or for revenge, and monetary profits. I will go over all of these 5 things here in a second, and we'll talk about them. So the first one was finding new solutions. So basically how your brain works is you have your left side and your right side, and they work together with each other, and they are good at 2 different things. The left side is good at critical thinking, and the right side more for creative thinking. And you can see here how they work together. So first, the left side tried to analyze the problem and the right side try to figure out a solution. Then the left side once again takes part here and try to evaluate the solution and say, nope, this was not good. Well, then it goes back, and the right side try to figure out a new solution, and it kind of goes back and forth like that. And we have like, oh, maybe if we do like this, nope, that won't work. Well, what about like this instead? And that's basically how the brain works. Well, at least kinda. So if we have a look at the critical thinking part, so the left side of the brain, keep in mind this is not same as criticism. This is not something negative. This is more like trying to questioning things like how, where, what if, and why. And by asking these questions all the time, you are basically opening up your mind for new ideas. And this can also protect you against many different harmful influences, such as scammers or marketing and politics, and also prevent you from ending up in dead ends. So, for example, we can take an example when it comes to phishing emails. So a hacker sent a phishing email to you, but you stop and think, why did I receive this email? Why have I won $1 million? Maybe there is something suspicious. That's what I mean with critical thinking. And by asking this question, you're often protecting yourself against many of these things here. And we can take another good example, which is the bugging when it comes to software development. You need to have the critical thinking. So we know, let's establish that we do have a bug. Now we need to figure out why. So how does this code works? And where is the bug located? Why does this happen? And why does it not the thing that we want to happen? And what if I change this into that instead? Well, that's kind of how debugging works. So we have asked all of these critical thinking questions when we do debugging in software development. And you can learn this mindset by practicing. So have a common thing and always keep repeating this. So have it as a lasting habit to always question things. You don't, of course, have to go overboard and be paranoid about things, but critical thinking, basically. Now, if we move on to the right side, the creative part, and this is where we can learn from others and also share with others. So this is, of course, not something that only the good hackers are doing. This is also something that the bad hackers are doing. So they are constantly finding new ways to trick user into bypassing different preventions. So once again, for example, new phishing methods, new types of vulnerabilities and things like that, and coming up with new exploits. But the creative thinking is also what brings the pleasure. So, for example, when you have found this solution and then yes, it works, or when you have found this bug and what was causing it, that's the creative thinking. Like, yes, now I found it. And this is also the part that things like, okay, so now I've solved this issue here. What if I would automate it or build into a pipeline, things like that, which is something that Tom probably will talk more about later. And this skill you can often learn by taking notes. I always have a notepad nearby, a paper one, and not on the computer, because that's how I like to take notes and learn from others constantly. Another motivator that I have found is that many hackers also want to have some kind of acknowledgement, which, for example, can be represented here by different leaderboards. So this is from Bugcrowd, HackerOne, and this is from Hack the Box. So this can, of course, be used, for example, either as a bragging or building internet clout, like, oh, look here, I'm over here and I'm famous and things like that. And you can also have this, for example, as a career opportunity to show that even though you may not have a education in cybersecurity or things like that, you can still build a career by only showing your portfolio or whatever you want to call it. Is correct here, because some men just want to watch the world burn. So that is one motivator. And another motivator is, of course, money. Just like Maya sang in the 90s, it's all about the money. So let's see if our new mindset, if we can put it into use and have a short demo. So if I do, let me see. Yes, here. So let's go to this web page here. So this is the web page of the, let me see if I can move this one here. So this is the municipality of Timisoara. And as a normal user or a developer or something like that, you would just look, oh, it's a nice picture here, and here's the town square. But as a hacker, you may do, for example, some other things. You may, for example, look at the source code by right-clicking and view source code. I can immediately see that this is a WordPress, because it mentioned WordPress here. But also I can see, for example, here in some of the paths, VP content, and that is something that is a dead giveaway, that this is a WordPress. Now, of course, as a hacker, we also want to know if what we can do with this here, if it is any important information or not. So, for example, I know that we can search for generator. And here we actually saw that there is this generator tag, WordPress 553. Now, some of you may say, what if I remove this one here? Then you don't know what version I'm on, and you can no longer find issues. Well, there is multiple ways of finding a version of WordPress. So, for example, I know that there is also this path called feed. Well, I couldn't find it here, but if I go to /feed here, I now have the RSS feed, and once again, we can see that the generator tag is printed here. So some of you may say, well, what if I remove the generator tag here and in the other place and so on? Then you don't know what version I'm on. Well, unfortunately, because hackers like to share, there are tools such as CMS-Seek that can find more than 180 different CMSs. And this one isn't too up to date. It is 4 months old, but there's more projects like this, such as Fingerprinter, which was updated only a few days ago. And if we go into the WordPress file here, we can see that if we can find a file called README, so we can go like this, /README. Now, how Fingerprint works basically is it takes all of this content here and generates a unique fingerprint. So if anything of the content here would change for like any of this, it will generate a new unique fingerprint. But if the fingerprint of this file is equal to this one, then it's some of these versions here. Now, as you can see, there is quite a lot of different versions. And if the fingerprint is this, then it may be one of these versions here. Now, we can keep on doing this for a bunch of other files too. So we can, for example, see that we have some more files here. And we can continue doing that until we eventually have only one fingerprint, and we know exactly what version it is. So just removing the generator tag won't help. I can always find the version anyways. So now when we know what version we were on, we can just Google it here. So WordPress 553. This was released in October, so quite recent here. In the end of October, and we can see that it fixes several security bugs. Now, if we instead search for WordPress exploits, we can find, for example, this WordPress vulnerability database, but we can also find things such as CVE details, which is this page here. And we can see here there is a lot of vulnerabilities, not too much interesting, but this one is a little bit higher. So have a look at that one. And we can see even more information. Version before 5.1.1 does not contain proper filtering, etc. And we can take this information here, and we can always take the CVE. So we can once again use Google. That's why I said that hacking is mostly Google, and we can find even more information here, like this one here. We can continue to drill down here to a blog post that actually does a really good deep dive here into what this particular issue is, like the impacts, a technical analysis, and so on, and how we can escalate it into a stored cross-site scripting. Now, I also mentioned VPScan, this database here, and this was the version that this particular issue was found in. But if we go to 553, which was the one that was used in the WordPress version for the Timo Shuhara webpage, we can see no vulnerability. But we can, as I mentioned, we can just go back here in time, and we can see no vulnerabilities here. But 551 did have vulnerabilities, and quite a few actually also. So then, of course, we can click on these deep dive and find more exploits, and we can also use that to actually exploit the web page. Now, what I'm not going to go any further. I'm only going to detect this. So what I just showed, of course, that's not anything illegal. And of course, you should always have explicit permission before you're engaging a target. But since I only were doing some open source intelligence and I did not actually attack the target, we are good. Now, I also mentioned the money. It's all about the money. So there is also something called bug bounty, which is basically a way for hackers to gain legal permission to hack a company or the resources, as long as they are, of course, in scope. And it's very important to read the rules and also, of course, to follow the rules. Otherwise, you may risk of not getting anything except for a prison sentence. Now, this is something that is still quite new, and there is quite a lot of money involved also here. So, for example, last year, Google paid out 6.5 million USD. And since 2010, they have paid out 21 million USD. So you can see that most of it have actually happened the last 2 or 3 years. So this is something that is still on the uprise. And here are some people that does this for a living. And we can, for example, see Tom here in the corner that will talk here in a moment. So if you want to read more or learn more about hacking and hackers' mindset, I wouldn't recommend to start to hack immediately, but actually to learn it in a good pace and doing it the legal way. So, for example, you can use sources as HackerOne here, and there is also for new hackers. There is also some good videos here. I mentioned Stuck before. And there is also some platforms that is kind of like game-based learning platforms called CTFs, and you can find a few of them right here. And OWASP also have a few good ones. They have one that is called UserShop and one that is called Security Shepherd. So with that, thank you for listening, and now we can have some time for questions.
Yes, I have one question for you. You said about critical thinking. How important is critical thinking into bug bounty and into hacking?
I would say very important, because without the critical thinking, you wouldn't question things, and you would easily end up in dead ends. So you will just be on the same endpoint and trying to find something, but you can never give up. And that's where the critical thinking comes in, and basically says that no, now I need to move on and try something else instead, and try something else. Well, then it is the creative part instead.
Yeah, cool. If there are any other questions, please let us know to chat or just raise the hand. If not at the end, yeah, we can have more time for questions. So just prepare those questions, and we can raise those at the end. So our next special speaker, it's Tom Nom Nom. So Tom, the stage is yours.
Thank you. I'll share my screen. And there we go. You should be able to see a title slide, and all should be well with the world. So yep. Hello, I am Tom Hudson. I do security research at Detectify. And if there's any of my colleagues watching, I apologize profusely for not having a branded slide deck. I've done this talk at a small user group before, so before working at Detectify, so the slide deck reflects that. So I'm Tom Nom Nom, basically everywhere online. I do a bit of bug bounty. I haven't done too much in the last sort of year or so for a variety of reasons. I love a bit of recon as well. And also, the reason I haven't really done that much bug bounty in the last sort of couple of years or so is I've been burnt out. I worked too hard without taking enough breaks. So just a reminder to take care of yourself. It's really easy when you get really involved and interested in something to just spend all of your time doing it and not making time for other important things. So take care of yourselves. So when I'm doing reconnaissance for, say, a bug bounty target or something like that, there's a lot of things that I like to look for. Some fairly obvious things, so like credentials, for example, if you happen to come across them, very useful. But also other things like internal URLs. So even if they're URLs that I don't have access to, maybe they're blocked by a firewall or other access control or behind a single sign-on system or something like that, they're still useful pieces of information. Unknown paths on hosts as well, so things that aren't linked are something I would really want to know about, because if they're not linked, that means they were probably supposed to be removed and possibly with good reason. So they could be interesting things to look at. Pieces of internal documentation as well. It can be very, very useful, explaining how internal systems work and perhaps some details that you wouldn't otherwise be privy to. But another thing that I try to look for is just what I've called internal indicators. And it's a bit of a vague definition, but this is anything that you shouldn't really know about as an outsider to the company. So it might be an internal URL as an example, like the URL for the company's intranet is something that you wouldn't ordinarily see in customer-facing documentation or blog posts and things like that. So anything like that, I think that's something only an employee should really see. I think that's interesting. Anything you probably shouldn't know. Because, you know, knowledge is power. Some wise dude said that a really long time ago. And genuinely, nearly anything can be useful. Even things that are seemingly innocuous can later be the difference between you managing to exploit something and not. So a standard way to find things, as Per mentioned, is with Google. So we Google for things, and you can just say, find me all of the things on this site, for example. So I'm going to use Spotify as an example. They have a bug bounty, public bug bounty program. Again, I'm not going to be attacking them directly, but still worth pointing out that there's a certain amount of consent here at least. And I think most people in the sort of pen testing, security, and bug bounty world are pretty familiar with Googling things. But you know, to the point that you can do things that are a little bit different. So rather than searching for a target directly, you might look at other external sources. So if, for example, let's have a look at Pastebin for instances of Spotify.net, where Spotify.net is an example of one of those internal indicators. So, you know, there's nothing customer facing hosted on that domain. It's all internal stuff. So in theory, at least, if I find search results about that domain, then they are potentially interesting because they're things that I maybe shouldn't know. So fairly standard stuff, and like Per says, the bread and butter of anyone doing this kind of work. Also, it's really easy to forget that not everything's on Google. So for things Google doesn't find, you can use Yandex or some other search engine. And that's it. That's my talk. Any questions? No, not really. So there are other search engines. So Yandex can be quite useful. I found it finds a few things that Google doesn't. Same deal for DuckDuckGo and Bing. Both of those sort of general purpose search engines. And if you're like me, you might have noticed that over the last, I won't say a few years, but perhaps even over the last decade or so, the results have become much better for your average human, but actually quite a bit worse for people looking for very specific things. So there used to be many more search operators and things you could use, and you could do searches for exact text that included special characters. And a lot of the time when you're running those kinds of searches, even if you choose Google's verbatim search mode, those things get stripped out. So if you're looking, for example, to find instances of a particular regular expression or something like that on Google, you might really struggle. There's other search engines that are more specific and a bit more tailored. So things like Census and Shodan and Zoomai, who all spider the web and pretty much all of IPv4 space, and possibly even some of IPv6 space. I'm not sure about that though. And store their results and make them searchable. They can be very useful too. Public www is another, which lets you search the source code of, I think it's the top 10,000 sites or something roughly like that, which is another thing that Google and so on don't really let you do. You can only search for text that's going to be visible in the browser when you load the page, rather than things that are in the source that you can't see. And there's lots more. This is not a comprehensive list, and they're all worth a shot, because that sort of knowledge is power thing, pretty much any piece of information is potentially useful. And if one of them reveals a web page that others didn't, then that means that not that many other people are going to have found that. It's not going to have been tested as much, and there's more potential for things to be there. So other search engines is a great idea. But also, I want to remind you to remember to look absolutely everywhere. So Google and other search engines are very good at searching text documents. But if anything's a binary file, an image or something like that, maybe not an image, but some binary blob of data, that's not going to get searched. So this is an example of a report of mine from quite a few years ago now, but one that really made me chuckle a little bit, which was there was a binary downloadable on a particular website. And in this case, it was for a company involved with broadcast television using set-top boxes. And this binary was an update file for one of these set-top boxes. And inside it were some credentials in plain text mixed in with all of the binary and all that sort of thing. So the Unix tool strings is really useful for doing that sort of thing. But always look in places, even when you think that there won't be anything there, because sometimes there is. Also find useful to look into the past. So you're probably familiar with the Wayback Machine provided on archive.org, which lets you look at what websites used to look like. And you know, that's useful and it's fun, because you get to go and maybe see your old MySpace profile and your first website that you made in the late 90s, or if you're me, or maybe some other time, a bit more recent, a few old GeoCities pages and things like that. Good fun. But also that unlinked content that we talked about was perhaps linked in the past. So it might be that in a previous version of a web application, there was some functionality that was linked and existed. And then when that functionality was retired, the link went away, but the functionality itself perhaps didn't, or perhaps it left remnants of that functionality behind. So that can be another really good way to find things, because those are the sorts of things that get taken out of search engine indexes because they're not linked anymore. And search engines like Google, although they're very private about exactly how their algorithm works these days, at least originally was based on how many pages link to another page. And if the answer is none, it's probably going to stop getting crawled. This is quite manual though. So one of the things that I like to do, oh yeah, that's a picture of Spotify's homepage looking nice and old in 2010 when they first appeared, is to use this tool, Wayback URLs. So this is something on my GitHub profile, github.com/tomnumnum. And what this does is it takes URLs on standard input. So you can echo a domain into it, and it finds all of the URLs that the Wayback Machine knows about for a particular domain. So we can see here, I'm searching on spotify.net. We can have standard stuff like the favicon and robots.txt, but also, these other paths, /melon/login with a return to parameter. What's that? I don't know, but it looks potentially interesting. And also other subdomains and things will turn up. And these are things that are, probably not going to show up in Google, either because they're not being crawled at all, or because they used to be crawled and they're no longer able to. So using this tool lets you go off and find all kinds of interesting places to look that you otherwise perhaps wouldn't spot without having to go and browse the sites manually, maybe proxying them through Burp Suite or something like that. There's another feature built into this tool as well, which if you give it a URL and a particular switch, which I can't remember off the top of my head actually, it will give you a list of URLs on archive.org for all of the previous versions of a file. So another thing you can do here is sort of say, well, I have suspicions that this particular file I'm looking at may have contained something interesting in the past. And you can ask Wayback URLs tool to give you links to all of the previous versions that archive.org know about. So really useful way to go about things. Speaking of robots.txt, which made reference to, if you're not familiar, robots.txt is a file that describes what a search engine should and should not crawl, or a robot originally, we would have called them. Any reputable search engine will obey these rules. So you can say, for example, I disallow you to search spider /webmail or /download/local. And one of the things that is perhaps an unfortunate side effect for the website owners of this robots.txt idea is that often you end up spelling out the paths that you don't really want people to be looking at. So one of the things that I've taken to doing is looking for robots.txt files and finding all of the disallow lines in the output. So here using a tool I wrote called Meg, which for our purposes just goes and fetches a particular path for lots of domains and stores them in this output directory. And then I can use grep to find all of the disallow items. And I get this nice big long list of paths that I can use in a brute forcing list or something like that. Or I can go and look at them manually, of course. But another place that I started looking for things was inside Docker images. So we talked about like looking inside a binary with the strings tool, but I had to still I had to find that binary on a URL somewhere and download it manually and look at it. But that kind of got me thinking about, well, what other stuff is Google not finding? What is not being searched? But I know I still have a fairly high chance of there being some interesting information. And it struck me that in this modern world that we live in of Kubernetes and microservices and things like that, Docker exists. And more importantly, in this case, Docker Hub exists, where companies may have pre-built Docker images that they've uploaded that they're perhaps using internally. And it might be that they're based fully on open source software, for example, but it also might be the case that if these are being built on internal infrastructure, there may be some artifacts left over as a result of that build process that can leak interesting information. So if I was to go and do that, firstly, a useful bit of information to know is when you run a Docker container, you can override the entry point. So it's a pretty common thing for a Docker image to have an entry point for a particular piece of software that it's going to run. So this is a Spotify Helios test container. I'm going to assume Helios is a piece of software, and when I run this container, by default, it's going to run that piece of software. But if I want to say run a bash shell instead, for example, I can make that happen fairly easily. One of the things you might find though is once you have a shell inside a running container, is you don't have all of the tools that you're expecting because they tend to be quite minimal. So this one, for example, does not have Vim, which makes me very sad because I like Vim. I like it a lot. So one of the other things you can do to make it a little bit easier to sort of interrogate the contents of a Docker image is you can gain file system access from the host. So this is perhaps a little bit involved, but if I get the PID, the process ID of a particular Docker container using Docker inspect and then the reference for the Docker container, I can use the proc file system, so /proc/the PID/root to find what that container views as the root file system. So I can see I've got this OpenJDK 11 SHA-256 sum.txt here, which is exactly the one that I was looking at here before inside the container. And now I can use my own tooling. So whether that's grep or some other custom built tool that I want, I can use that to search the contents of the file system. And one important little thing to point out here is this A flag on this grep command. So I kind of typed these flags without really thinking about it, but what they are is, so grep is a tool to find strings of text in files. Capital H makes it display the file name, N makes it display the line number, R is for recursive search into any subdirectories, I is for case insensitive. But the A causes grep to treat binary files as being text files. So you can see one of these results down here, there's a bit of gibberish looking things, some characters that don't quite work and that sort of thing. And what would happen by default is grep would say, if it encountered this file, binary file matched or something along those lines. But with the A flag, it will still provide the output even when it's a binary file. And you can find some interesting things there, as so the set-top box download. But one of the really nice things that you might find, as I did and got kind of lucky on, was some credentials. So this was from a Docker image on Docker Hub, built by a company that has a bug bounty program. And although everything on it in theory was open source, they'd used their own internal PyPI mirror for installing packages on this image as it was built. And the configuration file that stored the credentials to be able to access that PyPI mirror still existed in the Docker container. And I was able to access private packages and source code on that. So I managed to get $7,500 for that, which was pretty exciting. So another place to look, as well as Docker Hub and that sort of thing, is GitHub. Google does an okay-ish job of searching GitHub, but not quite as good as GitHub's own search engine. But I'm always forgetting about gist. So if you're not familiar, GitHub allows you to post this tiny sort of single file or few file repository on gist.github.com for sort of notes and other small things that aren't quite deserving of an entire repository. And it turns out that quite a few people use Gist to store things like the output of some command or the contents of a log file that they need to share with someone quickly. So there can be some interesting things to find there too. And of course, searching GitHub itself, also very useful. But again, can be quite overwhelming. So searching for Spotify.net here, again, that sort of internal indicator, I find some references to things that I perhaps shouldn't know about. So artifactory.spotify.net down here is almost certainly some internal Spotify Artifactory instance. It's not externally accessible, but that piece of information still lets me know that firstly, they use Artifactory, and secondly, if I have some other vulnerability, like an SSRF or an RCE or something like that on Spotify infrastructure, then maybe this is a URL that I can try and access. Whereas, without that, I might pass over the other vulnerability by not being able to find anything interesting to gain access to. It's still very manual though. And there's another thing missing here. So it's kind of like the same problem again, where Google's not finding certain things, so we look elsewhere. The GitHub search isn't finding lots of things either. And the reason for that is GitHub is going to search the default branch in the latest revision. So the head of master usually. And if it's not in there, it's not going to get shown in search results. And that's understandable because to be able to search every revision in every GitHub, every Git repository on GitHub would require a fairly substantial amount of hardware and resources on GitHub's behalf. If they ever solve that problem, I will be very happy. But in the meantime, I decided I want to come up with a way to search the history of a GitHub repo fairly easily. So if I take a local clone of a Git repository, and it turns out I can actually dump all of what are called the Git objects. So this is a fairly nasty looking shell script, of which there's a more useful version of linked at the bottom of the slide. But what this is doing is finding all of the packed objects in a Git repository. So if you're not familiar, Git will take individual objects, which are files and commits and things like that that exist in your Git repo, and compress them all into one file called a pack file to get better compression ratios and things like that. So I'm finding all of the pack files and using the Git show index to say, tell me all of the commits that appear in this particular, in the index of this particular pack file. I'm additionally, in a separate command, finding all of the other Git objects that are not pack files. So this grep-v pack here removes all of the pack files. And for all of those, I can use git catfile-p to output the file itself. And that produces a text stream which contains all of the text that has ever been in a Git repository, in the commits and in the files themselves, and any other metadata that's in there. So it's a fairly clunky way to work though. So I have this other script, which I want to give you a quick demo of, along with a couple of other things that I will use from time to time. So Spotify's GitHub page up here. And one of the things that I think is really useful, very helpful of a corporation is to tell you about lots of people that work for them. Because humans, being the squishy meatbags that we are often the weak link in an application. So I could go and look at all of Spotify's repositories, but what I'd really like to do is go and look at the repositories belonging to Spotify employees instead. But that would take a long time. So I wrote a few tools and things to help me out. So the first one is this tool called GHTool, and it has a facility to search for the members of an organization. So if I run this and get a list of members and put them all into a file, you can see a list of all of these people. And then I can do something like take the list of members and say, while I can read into a member variable, so each line of text, I'm going to run GHTool repos against that particular person. And then I'm going to store the output in a file called repos. And I am going to miss a little bit of bash syntax. There we go. So what that's going to do is run that GHTool tool against every person in that list and find all of the repositories for them. And most of them are going to be boring, but some of them won't be. So I'll just stop that running now. It's going to take a long time. So if I have a look at this repos file, you can see I've got lots of repositories, 291 of them to be exact. And I can take those and say, I am going to use xargs with 1 argument per command with a concurrency of, let's say 10, and use this little tool called gclone. It's just a small shell script that clones. You could use git clone instead, actually, and it would do more or less the same thing. And this is going to go off and try and start cloning repositories, and put them in this directory called github.com. But that's probably like a few too many to go at. So what I would rather do is look for interesting repositories. So I might think, for example, that any repo called .files or config or Spotify might be interesting. So I'm looking for Zoom things in my way. I can't see what I'm doing. Any sort of local personal configuration repositories that people are using to set up their personal workstations. Because if you work somewhere and you use a lot of infrastructure and things like that, and you have your own home personal machines and things, your home life and work life might bleed into one another a little bit. That's sort of my hypothesis. So I'm going to do this, and I found 5 repositories here that match those specifications. So there's one called .files, there's a Spotify repository, an effortless-config repository, and I'm going to use this instead. So same deal, I'm going to use xargs with a concurrency of 10, and I'm going to go off and clone those repositories, which there's not too many of now, so it doesn't take nearly as long. So if I pick on just one of these particular repositories, so .files one, which is empty, so that was the wrong choice. Let's have a look at this one instead. So we have a repository that we've cloned, and I can use grep to go and find things. So I might find, for example, 123 instances of the word Spotify in this repository. And that's great, but I've not really improved too much over the GitHub search in the situation. So what I would do instead is use this git dump tool. So somewhere, just have a look at it. We can open in Vim actually, why not? So it's a fairly short shell script, and it's on GitHub. There's a link in the slides, and I'll share the slides when I'm done. I'll upload them somewhere and put them in the chat or something. So this does more or less the same as the command that we saw on the slide before, except it puts each object into its own file. So if I run that git dump script, it'll take it a second, and it's created a directory called git objects. And in there is one file for every single object in that Git repository, which means every file that has ever been in that repository, whether it was deleted straight away or whatever. So, and here we see 242 results for Spotify instead of the 123 that we had before. So something I might do there to try and narrow things down a bit more is to say, well, I don't want the file in the line number anymore. I'm going to pipe the output of that into Vim. My apologies. I need a small h to suppress the file name. And now I have a list of results that I can look at in more detail. Perhaps more importantly, I can sort them with a unique flag, which is, I just used a keyboard shortcut to do that. So I apologize. So if I do a colon exclamation, which means the current buffer, and a bang, which means run this command in the shell, I can say sort-u and that will remove duplicates. So now there's only 99 things to look at instead. And I can look at each one of these individually or in the list and see, does this thing look interesting or not? And if it does, I can go off and look at that thing specifically. So let's have a look at the Spotify service get instance, for example. I can search for the word under the cursor and find all of the instances of that particular piece of text and continue from there. And look into anything that might crop up. So really nice way to be sort of finding these things that aren't going to show up in other situations. You can go a little bit too far with it. I think at some point I ran out of inodes on my hard disk because I had cloned so many repositories and created so many files, which was a little bit unfortunate, but you do have to be a little bit selective about what it is you're looking at. So that kind of a reminder really about that -A sometimes is the difference between finding something and not, because it appears in a binary file that grep would ignore by default because it thinks you're looking for human readable text only. Note on viewing objects directly by their hash, you can use git cat file-p for that. P is for pretty. And if you're really lucky, lucky AF, as it were, you might find perhaps a certificate in a binary file that was otherwise ignored by all searches and things like that, and including Trufflehog in this case, which very, very luckily for me resulted in a $40,000 bounty for getting access to all of somebody's internal source code. So it can work out pretty well. So that's it from me. Thank you for listening to me. I'm really interested to hear your ideas and other suggestions for places that you can look for information that's not ordinarily going to be returned by search engines. And also just ask me questions in general. And I'll try and get the slides online for you as soon as I can. Thank you.
There are a couple of questions to the chat. So the first one is if you automated the Docker searching for Wayback URLs.
So I have not. I'm not aware of a way to do a search like that on Docker Hub. So the Wayback URLs tool uses the archive.org API in order to work. I have been considering writing some tooling around making it a little bit easier, sort of more similar to the GH tool thing for like finding the members of an organization on GitHub, doing something equivalent of saying, tell me about all of the Docker images that exist for a particular organization, for example, and maybe automating, fetching them all and letting me search through all of them at once. I think that's a really good idea, but I have not had the chance to do it.
Sounds cool. And for the Docker images, what is one cool finding that is not shared or not published through HackerOne? Or
so the finding of credentials in the Docker images is the main one that I want to share. I have a few others I can't really talk about, unfortunately. I couldn't tell you who that one was for, but there are definitely potentially things to find. So it's what I will say is it's worth looking inside binary files in containers as well. Occasionally you will find images that were built with compiled artifacts only, but those compiled artifacts were compiled on internal infrastructure and themselves may contain data that perhaps the people who built them weren't expecting.
So nice. This is Tom using his creative mind, because I don't know too many hackers that are actually doing what you're doing with the binary files, at least. They are more specific on web application security, such as cross-site scripting and things like that. So,
yeah. Oh, and we're not all just hooded guys in dark garages. was the other thing that I wanted to mention. I'm doing nothing for the stereotype. I apologize, but hoodies are comfortable, and black goes with everything.
Another question that we have, it's do you have a couple of commands that you already used into right now in your Git repository? Or
so I have a couple of things. I have a video I did with my friend Stock, which is called something like, let me find it, and I'll paste it in the chat. Where I go over the general techniques for how to do that sort of thing, including a bit of looking at the Git repository like we did just then in a slightly different way. And I explained the commands in more detail. I didn't want to go into too much detail because I knew we were slightly pushed for time.
Yeah, unfortunately, due to the bad beginning, that was not supposed to happen. Another question that we have, it's about when you create the recon tool, how do you prefer to parse the results of different engines like Chances, Shodan? And do you create the complete search or use other engines?
So it varies, is the answer there, if I've understood the question correctly. So search engines like Census and Shodan and stuff, their indexes are too big for me to have locally, for sure. Very difficult for me to have those myself. So I will try and use APIs where they exist. But for creating my own search stuff, that is something I have done. So I'll give you another link in the chat, which is to a tool built by Google called CodeSearch, which is a local indexing system capable of doing regular expression searches and things like that very, very quickly, provided you've taken the time to pre-index everything. So I've been using that quite a bit across GitHub repos and that sort of thing. So I have some nasty hack together scripts that will fetch a load of repositories and then run a code search index across them so that I can look for things across, several tens of gigabytes of data with sort of 1 or 2 seconds or so for the results to appear, which is very useful. Also, invest in fast storage is the other thing. NVMe SSDs are great. I'd really like to get my hands on one of those Intel Optane PCI Express drives as well at some point. That would be really nice. They're expensive for what they are.
So how much do you run locally on your own machine, and how much do you use like AWS or other solutions like that?
So for a lot of my reconnaissance work and that sort of thing, I will use a DigitalOcean droplet. The fixed predictable pricing, I think, is preferable for this kind of thing. I think I'm terrified that if I launch something on AWS and run the wrong command, that I would go bankrupt. I've seen a few horror stories in that scenario. I do a fair amount there, but when it comes to the real heavy searching stuff, I end up doing a lot of that locally because for the cost of 1 month of having a machine capable of doing that stuff, I can buy a new SSD. So like online fast storage is expensive, especially because, with that amount of data, you don't want to be spinning it up and tearing it down all the time. You want it to last for a year or more, or maybe as long as you can. So I tend to do that stuff on a local desktop machine that's behind me.
Cool. Another question that we have is what is the margin between using your own tools and the mainstream or even more obscure tools when you're doing some bug bounties or looking for some vulnerabilities?
Yeah, so if I had to guess at the split, maybe it's about 50-50 or something like that. So I have written what some might describe as too many tools, many of which are exceptionally poor quality. So I have a repo called Hacks, which contains about 24 sort of proof of concept half-finished tools. And then maybe a dozen or 24 other tools that have their own repositories. They're all very small and focused. I'm quite a big fan of the Unix philosophy of doing one thing and doing it well. So I tend to build tools in that style and have them built so that they're composable using the sort of the bash pipes and that sort of thing like we saw earlier. I do also use a bunch of other tools that other people have written. So FUF, F-F-U-F, which is a brute forcer, fuzzer sort of tool. It's very, very good. It does a whole bunch of stuff that I was intending to write in my own tools. So that's very useful. I use Burp Suite as well, as probably 90% of people doing these kinds of activities do. It's hard to beat for the amount of stuff that it has and the power, especially the plugin ecosystem. It's very good. But I do use my own tools a lot as well because they work exactly the way I want them to, and do things like not print out big ASCII banners. You know, sort of the hacker aesthetic, as it were, of ASCII art and banners and on tools and things. I love it. I really, really do. But it's not conducive to an efficient workflow, unfortunately, when it comes to piping text into other tools and grepping for it and so on.
And which one it's your programming language, the most preferred one? Go, Python, what?
Yeah, so most of my tools are written in Go. I would say it is my favorite language, partly because of what it doesn't have, perhaps ironically. So the main sort of meme for Go is, oh, it doesn't have generics, right? And I'm fine with that because generics being very powerful is great. But with great power comes great responsibility, as a wise man once said. And that means there's a lot more room for the code to be complex. And I'm a relatively simple guy. I like to keep things as simple as I can so that I can understand them. Like I'm a fairly mediocre programmer, I think, in terms of, like, I don't have a computer science education, for example, so I will kind of struggle a bit with functional languages, and when things get into like generics and templates and metaprogramming stuff, I start to find it harder to read code, and I tend to prioritize the readability of code over most other aspects. But the other thing that Go has going for it is its sort of default artifact is a statically linked binary, which will run just about anywhere. So for a lot of my tools, if you want to use them, you can just download a binary and run it. Whereas, like, every time I use a hacking tool written in Python, I have to sit and figure out, you know, is this going to be an easy install or is it going to be a pip install? Do I need to make a virtual env? Are all of the requirements I need still existing, and so on? Whereas, and you know, Go can have some of those problems as well, building from source. But the fact that you can just download a binary and run it and it works is super, super useful.
I see that there are no other questions. Maybe, Per, you have some questions?
No.
So thank you.